Okay, so today's topic is going to be, today's topic is order trig ratios and applications. No, I'm sorry, order trig identities and applications. Order trig, okay? So now, we are just going to use the one we know, the one we already know and established. We are going to use it to establish other ones. Okay, so first of all, let me write a few of them. You know your SOHCAHTOA, and from a unit circle, so we determine that tangent theta is equal to sine theta over cos theta. So that's another thing we know. So we know this is 1, this is 2. And then the third thing we know is that sine squared theta is equal to, not equal to, sine squared theta plus cos squared theta is equal to 1. So this is basically where we are starting right now. So you can substitute equation 2 into 3. So substitute or plug in. Some of you like it to call it plug in, but if you are writing a standardized test, if you want to explain your point, use the word substitute. So substitute equation 2 into 3. Okay. Actually, before we do that, let's do one more thing, please. You can cross out this statement. I'm going to repeat it, but let's do one more thing before I write the statement. I need to write one more additional statement in between. So just cross it out. So you can say divide equation 3 by sine squared theta. Divide equation 3 by cos squared theta. That means every term in equation 3 divided by cos squared theta. You can as well divide by sine squared theta, but let's divide by cos squared theta and see what it gives us. We are just trying to manipulate and create more equations. So if we do this step that I just wrote, it is going to give us sine squared theta divided by cos squared theta plus cos squared theta divided by cos squared theta equal to 1 divided by cos squared theta. Okay. So now you can see that cos squared theta divided by cos squared theta gives you 1. And on the other hand, sine squared theta divided by cos squared theta will give you tangent squared theta. So this will give you tangent squared theta plus 1 equal to, then recall your trig ratio, the other trig ratios. Second is 1 over cos. All right. Note that secant theta is equal to 1 over cos theta. Therefore, secant squared theta is equal to 1 over cos squared theta. So if we plug in this back here, so we are going to obtain that tangent squared theta plus 1 equal to sec squared theta. So that's another trigonometric ratio that should be, this thing should be on that, it should be on the identities that we just talked about. If you look at that identity we talked about, it's right there. Okay, so this is another very important trig ratio.
Wait, can you please go back out?
Yes. This is where we just started. Okay. So, now you see the reason why I don't really care about so much of this formula is, like I keep on saying this thing, once you master how to get the process, you will generate those formulas by yourself. Okay, so now let's do one more and then we will now do the applications. So let's derive the next one. The next one would be, instead of dividing by cos square theta, we can divide by sine square theta. Okay, so we can go ahead and say divide equation 3 by sine square theta. So divide equation 3 by sine square theta. Okay, so that's going to give us, if we perform that division, that's going to give us sine square theta divided by sine square theta plus cos square theta divided by sine square theta equal to 1 divided by sine square theta. So we just did this by following a simple rule of equation. Whatever you do to the right side, you must do to the left side. Whatever you do to the right side, you must do to the left side. That's how we are following. So now sine square theta divided by sine square theta is going to give us 1 plus, let's go to the right side. On the right side, we know that cosec theta is equal to 1 over sine theta. Therefore, cosec square theta is going to give us 1 over sine square theta. So we just replace the right side. We just replace it with what? We replace it with cosec theta. So cosec square theta. Now, on the other hand, look at this one. Look at this third one, this one. So let's try to evaluate it a little bit. Let's try to evaluate it. We know that cotangent cot theta is equal to what? 1 over what? Tangent theta. And tangent theta itself is, tangent theta is sine theta over cos theta. Okay, so if we plug in tan theta here, we are going to get, if we plug in this here, we are going to get 1 divided by sine theta over cos theta. So now we use keep, change, flip. We keep 1, we put multiplication, we flip the other one, that gives us cos theta over sine theta. So at the end of the day, cos theta over sine theta gives us cotangent. So that means cotangent of theta is equal to cos theta over what? Sine theta. So if you have it, if you square it, cos theta squared is equal to cos square theta over sine square theta. So then we are just putting this back to this place. And that will give us 1 plus cos theta will give you cosec square theta. I'm sorry, 1 plus cos square theta will give us cosec square theta. So that's the other trig identity that is in that paper. See, that's the other trig identity that is in that paper, in that reference sheet that I just gave you. All right, so now in some questions, they will ask you, prove that or show that. If they say, show that 1 plus cos square theta is equal to cosec square theta. If they say, show that 1 plus cos square theta is equal to cosec square theta, if that's the question, then you need to do what I have just done here. If that's the question. So if they are asking you to prove the formula, then you need to do this. On the other hand, if they are not asking you to prove the formula, then just use the formula and solve the problem and move on. Am I making sense? So if they're asking you to prove the formula, then you have to write all these. But if the question is just giving you a problem and asking you to solve the problem, just copy the formula and use the formula. Copy the one that you see on the reference sheet that is applicable and then use it.
Are we gonna do like a equation using this formula?
What?
Are we gonna do an equation using this formula?
Yes, we are going to solve a problem right now using the formula. So we are going to use this formula, this one, or we are going to use this one, or we are going to use any of these other ones like the SOHCAHTOA and things like that.